In this video, we're going to talk a little bit about the difference between Newtonian notation and Leibniz notation, and then after that, do an example to determine the derivative, more specifically involving velocity. So Newtonian notation says that the derivative of a composite function is equal to the derivative of the outside function times the derivative of the inside function. Leibniz notation states that we have the derivative of the u sub times the derivative of the inside piece. Both of these equations yield the same result, however, they were just thought of in two different ways. There's a big controversy about who's the creator of calculus, and the debate is between Newton and Leibniz. These two people were in two different locations, however, they discovered or created calculus around the same time, just through different methods. It doesn't matter which one you use to find your derivative, you'll end up with the same result either way. So in example 3, we have that an object moves along the x-axis so that its position at any time when t is greater than or equal to 0 is represented by x of t is equal to cosine of t squared plus 1. Now what we want to do is determine velocity. Well, I know that velocity is the derivative of position. So that means that I'm going to take the derivative of cosine of t squared plus 1. My preferred method is to use Newtonian notation, but either way will work. So I'm going to let cosine be my f of t, and I'm going to let the t squared plus 1 be g of t. So what I like to do is do all my work off to the side and then just write in the answer when I'm done. So I have f of t is equal to cosine of t. So the derivative of that is negative sine of t. And I have g of t is equal to t squared plus 1. So the derivative of that is 2t. So then the derivative of my entire function is going to be my outside piece, which is negative sine, and then the inside piece goes in here, so t squared plus 1 times g prime of t, which is 2t. So it's the derivative of the outside, and then you leave the inside alone, times the derivative of the inside. So then my final equation is going to be negative 2t sine of t squared plus 1. So now on your own, I'm going to give you that the position formula is sine of pi over 3 minus 2t, and I want you to determine the velocity. So what we're going to do is we're going to identify our outside and inside function. So my outside function is sine, and my inside function is pi over 3 minus 2t. So f of t is sine of t. So f prime of t is equal to cosine of t. And then g of t is pi over 3 minus 2t. So g prime of t is just negative 2. So my velocity function then is going to be cosine of pi over 3 minus 2t times pi over 3 minus 2t with the derivative. So it's the derivative of the outside times the derivative of the inside. So I get cosine pi over 3 minus 2t times negative 2. So my final answer is negative 2 cosine pi over 3 minus 2t.